In this project, we will simulate a sea robot's motion immersed in the water using the dynamic mesh method.
By clicking on the subscribe button, you will be informed about the newest CFD training videos by MR-CFD. Or if you are watching the training video, click on the MR-CFD logo and subscribe.
And if you click on the outlet boundary, you can see that the type of this boundary is defined as pressure outlet. Now, just like the previous boundary, if you click on the edit button, you can further change the settings for this boundary. In the appeared window, the most important point you should pay attention to is the gauge pressure, which has a value of 0 Pascal, meaning that our water liquid inside our computational domain will exit it to the atmosphere. Here, it should be pointed out that all of the wall boundaries have same condition, which means that they all are defined to have stationary wall motion along with no slip shear condition. After clicking on the Profiles button in the appeared window, all you have to do is to click on Red button and then select the profile file, which is sent to you with the rest of the files. Now, if you double click on the Dynamic Mesh button, in the middle part of the Fluent software, you can see we have enabled the Dynamic Mesh option, and underneath it, under the Mesh Method section, we have enabled two options of smoothing and remeshing. By clicking on Settings button, we can further adjust the specifications. Under the Smoothing tab, you can see we have selected the diffusion method, which is a method for increasing the quality of the newly generated mesh. By clicking on Advanced button, you can see the details of the selected diffusion method. There are two ways to check that your simulation process have reached convergence or not. Alongside checking the residuals reaching and nearing zero, you may define an arbitrary report or arbitrary boundary in order to calculate different parameters like pressure, velocity, temperature, and see whether they reach a constant value or not. If yes, it may be a sign that your simulation process have reached convergence. However, you must check the residuals as well. To create such report, you can simply right-click on Report Definitions, go over New, and select one of the options available based on your simulation. After double-clicking on the Residuals button, a new window will appear. In the Appeared window, you can see the absolute criteria for equations like continuity, x velocity, y velocity, and so on. Now, when you set the software to start the simulation, there would be error between each iteration. Now, if that error is less than these criterion, it conveys the meaning that that equation has reached convergence. And finally, in this slide, you can easily see the streamlines or path lines inside our computational domain, and you can easily see the path lines showing the vortices generated due to the movement of our robot inside our computational domain. Finally, a summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
To benefit from MR-CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.